In the annals of human thought, few discoveries have reshaped our understanding of the universe as profoundly as Albert Einstein's general theory of relativity. But to truly grasp the significance of general relativity, we must journey back in time to an era when the fabric of space and time was yet to be unraveled. This video series will explore the concepts of general relativity, its exotic mathematical nature, the seemingly impenetrable world of tensor calculus, geodesics, to the highly serpentine nature of Einstein's field equations, all through the lens of general relativity's evolution and historical context, offering a comprehensive exploration of this revolutionary theory. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to the series of videos on the story of general relativity. First, we start with a basic introduction of what and how we are setting the context and what we are going to learn about. Einstein's seminal papers of 1905 sent shockwaves through classical physics, challenging the fundamental assumption. They questioned the wave nature of light, provided compelling evidence for the existence of atoms, reshaped our understanding of space and time, and unveiled the equivalence of mass and energy. Now, the revolution initiated by Einstein's special theory of relativity in 1905 quickly revealed its limitations. Obviously, the attempts to reconcile Newton's established law of gravity with this theory provided unsuccessful without compromising fundamental principles of mechanics. Now, while the discrepancy did not immediately prompt empirical inquiries, it prompted Einstein to re-examine the concepts of space and time in 1907, ultimately leading to the groundbreaking theory of general relativity in 1915. Einstein's journey from 1907 to 1915, as you can see that the curve is going up and down, was a tumultuous odyssey marked by myriad of challenges, setbacks and triumphs. Fueled by relentless pursuit of truth and understanding, Einstein encountered a roller coaster of emotions. Amidst the backdrop of scientific inquiry and scrutiny, Einstein faced moments of frustration and doubt as he navigated uncharted territories of theoretical physics. His initial attempts to extend the special theory of relativity to encompass gravity met with formidable obstacles, leaving him grappling with unresolved contradictions and perplexities. Yet, undeterred by setbacks, Einstein persisted to his quest for a unified theory of gravity and electromagnetism. Despite encountering failures along the way, each setback served as a catalyst for renewed determination and innovation. Amidst the trials and tribulations, there were moments of breakthrough and revelation. Einstein's relentless pursuit of truth ultimately culminated in the birth of his magnum opus, the General Theory of Relativity. This groundbreaking theory not only revolutionized our understanding of gravity, but also reshaped the very fabric of space-time. Thus, Einstein's journey from 1907 to 1915 stands as a testament to the indomitable human spirit and the power of perseverance in the face of adversity. A chronicle of three locales: Prague, Zurich and Berlin. Now, as you can see right on your screen, the man in this picture is considered to be an expert on Einstein. Now, he actually is a professor emeritus of physics and director of the Center for Einstein Studies at Boston University. His name is John Stackel, became the first editor of Einstein papers, and you can go through internet searching by his name. You can find a myriad and millions of papers which relates to the life of Einstein, the works of Einstein, his philosophical implications, and a lot more. Now, you might be thinking that why I'm considering the name of John Stackel right at this moment. Now, the entire odyssey of Albert Einstein, Professor John Stackle describes as a trilogy of dramatic stages. And this starts off Einstein's journey from 1907 to 1915 that unfolds with compelling intensity and progression. In 1907, the stage was set with Einstein's introduction of the foundational concept he termed as equivalence principle. The second act unfolded in 1912 as Einstein's insights revealed that the gravitational field could be expressed through 10 space-time coordinate-dependent function, which comprises of metric tensor and reflecting the non-Euclidean geometry of space-time. Finally, on November 1915, the triumphant conclusion arrived as Einstein crafted the gravitational field equation, elucidating phenomena such as the anomalous precision of Mercury's perihelion and bringing his groundbreaking theory to fruition. Now, these are the three stages which Professor John thinks, and we will explore one by one that these are the ways in which the theory of general relativity was truly discovered. Now, apart from these three stages, there is an alternative script for the captivating narrative, which we will look into this video, which delves into the spatial context. Now, Einstein first conceptualized the equivalence principle during the tenure, I would say his tenure, at the patent office in Bern, articulating his ideas in a review article on special relativity in 1907. Einstein also examined the immediate ramifications of this principle, which includes the deflection of light rays within gravitational fields and the influence of gravity on the passage of time. This initial exploration serves as a prologue to the true unfolding drama, commencing in 1911 when Einstein embarked on a journey to Prague. Now, this is something which we are going to look into it, and I refer to this period as a chronicle of three locales because each city became a distinct stage for a particular chapter in this unfolding journey. Each location offered a unique social and political backdrop while also marking distinct phases in Einstein's family life. The interplay between these circumstances and his scientific endeavors has been explored in various biographies detailing his life and work. Prague, Zurich, and Berlin. Prague, 1909. In the illustrious year of 1909, Einstein was bestowed with the esteemed title which is called an extraordinary professor at the University of Zurich. Now, in German, in general, extraordinary professor is a professor without a chair, often in a side area or being subordinated to a professor with chair. This marked significant milestone to his career as he ascended to a position adorned with both academic reverence and public admiration. With the ink scarcely dry on his appointment, destiny beckoned once more as within a mere span of 6 months he was graciously presented with an even grander opportunity. The coveted position of full professorship awaited him at the esteemed German division of Charles University of Prague. This special offer happened because there was an unexpected job available in the field of theoretical physics at the university. It called Einstein to a higher level of respect in his academic work. Now, this, I would say from University of Zurich moving into Charles University of Prague, this was actually, I would say, fomented, or there was a person who actually did that, and this is the name of the person, Professor Anton Lampa, a professor of experimental physics and a passionate follower of Ernst Mach's ideas, played a significant role in advocating Einstein's candidacy for this position. So, as you can see, these are few of the significant, I would say, highlights of Professor Anton Lampa. So, Einstein scholars agree that it was Professor Anton Lampa who played a decisive role in appointing to the German University of Prague. He was born in Budapest in 1868. Anton Lampa spent his childhood in Bohemia. He had close personal ties with Ernst Mach and was deeply influenced by his philosophy. He considered the theory of special relativity a late triumph of Ernst Mach, and this was the main reason for him to support Albert Einstein's nomination of theoretical physics in 1911. And he supported Einstein as a candidate for the chair of theoretical physics at his university. As we say that behind every successful man there is a woman, so behind every successful I would say aspirant theoretical physicist there is a professor who would definitely help, and so was Professor Anton Lampa. Now this Ernst Mach's policy and Ernst Mach philosophies, I would say, we would look into the later part in the later episodes of the video, played a very important role. Now we look into how and when Einstein moved into Prague. This is the photograph of Mileva Maric with her two sons, Hans Albert and Edward. So after some deliberation and despite Mileva Maric's reluctance to depart from the familiarity of Zurich, where he found solace, and notwithstanding the pleas from student to university officially to retain him, Einstein agreed to the invitation and journeyed to Prague on April 1911. Now this is the 3-bedroom flat which he moved at Lesnica at 1215 to 7. As I can see that this is actually the building, and Einstein spent 16 months, remember, in Prague, and he lived in a 3-bedroom flat with his wife Mileva. And the apartment building is located at so and so location. As you can see, I have mentioned the screen, on the west bank of the Vltava river in Prague's working class Smychov district. And the new building actually had electricity, which was considered a big novelty at that time. Now as you can see, this one which I just highlighted actually contains a plaque with a life-size sculpture of Einstein's head. And if you are visiting Prague, please don't forget to visit this particular building, and you should take a photograph of yours behind or standing under the bust of the great Albert Einstein. Now, while staying in Prague, Einstein moved around, so his journey to work was just under 20 minutes. Retracing his steps, he would cross the Palacky Bridge, walking through the Namurani Street, past the famous Faust's house, and then he would reach the Vincinia Street 7, which now belonged to the Faculty of the Natural Sciences of Charles University. So he worked as a professor at physics at was one known as the German university, known as the Charles University, and he actually got a salary of this much, and he had 20 students including 2 women. Now, while staying in Prague, Einstein was invited for the first time to the first legendary Solvay Congress. I have already made detailed video on Solvay Conference and why it is important. And he met Planck, Lorentz, Madame Curie, Poincaré, most of them for the first time. And scientists also came to Prague to visit Einstein, and one of the most important was none other than Paul Ehrenfest. Now, apart from this job, staying at Prague, doing all his researches at the Charles University, Einstein spent a lot of time in music and philosophy also. Now, he immersed himself in the company of circle of Jewish intellectuals who congregated during the twilight hours at Berta Fanta's residence. Don't worry, I will tell you who was Berta Fanta, where a spirited discussion on philosophy ensued amidst the harmonious strain of music. And it was within this gathering that he encountered Hugo Bergman, a native of Prague, Austria-Hungary, and an esteemed member of the city's intellectual elite, who frequently visited the salon of Berta Fanta. Also presented was Max Brod, a Bohemian-born Israeli polymath, revered as much for his literary prowess as for the musical composition and journalistic endeavors. And who doesn't know him? Franz Kafka, a luminary German-speaking Bohemian Jewry, graced these gatherings with his presence, his literary oeuvre transcending the bounds of time to secure his position as one of the preeminent figures of 20th century literature. Now, if I trace back and go to the current salon of Berta Fanta, Berta Fanta was a woman who was a connoisseur of art and music, and he called all those people, Bergman, Max Brod, Kafka, and Einstein to this particular coffee shop, which you can see right on the screen. So Einstein would visit Berta Fanta's salon at Old Town, and if you're visiting Czechoslovakia, don't forget to visit this place also. And it is said that Einstein gave lectures and played violin with Max Brod, and legend has it that one night Kafka read some of his short stories while Einstein accompanied him on the violin. Now, if I go back to this picture and highlight this one, I mean to say this bust of Einstein, then you would see it. I can this magnify onto this part, and this is actually what it is written. The plaque, it contains a curly writing of equal to mc square, and it writes that here in the salon of Mrs. Berta Fanta, Albert Einstein, professor at Prague University in 1911 to 1912, founder of the theory of relativity, Nobel Prize winner, played the violin and met his friends, famous writers Max Brod and Franz Kafka. This is written in English. So the plaque was erected on the wall of the House of the Unicorn in Prague's Old Town Square on the 120th anniversary of Einstein's birthday, 14th March, on the 14th of March in 1998. Now, his then wife, Mileva Maric, who was the only woman among Einstein's fellow students in Zurich Polytechnic, found herself discontent in Prague, facing challenges due to the lack of fluency in Czech and struggling to acclimate to her new surroundings. The couple's relationship became strained, marked by incessant arguments, despite Einstein's admiration for Prague's beauty, as he tells that so beautiful it would justify live here a lot longer. He eventually yielded to Mileva's wishes, who urged him to pursue a different teaching position in Zurich, and after 1912, thereby conceding victory in their dispute. Now, this, I would say, difference of interest, or this problem with Mileva Maric and Albert Einstein, is going to take a decisive turn in terms of Einstein's career. Whether good or bad, we will come to know in the later part of the video. Now, staying in Prague, Einstein did some phenomenal work, and we are going to look what is the type of scientific work he did staying in Prague, coming up into the next part of the video. Now, you see, in Prague in 1909, Einstein wrote 11 scientific papers, out of which 6 of which were devoted to relativity. In the first 3 papers published in 1911, he discussed the bending of light and the gravitational redshift, which he had already discovered in 1907. And it explored, but this time he explored with some what is called observable effect. Now, observable effects means that it refers to the prediction made by the theory that can be observed and verified through experiment to the observation. Now, during this time in Prague, Einstein endeavored to construct a cohesive theory of the static gravitational field, drawing upon the equivalence principle. Now, similar to Newtonian gravity, this theory incorporated gravitational potential described by a single scalar function. We'll come to that later. Now, this function was now represented by a variable speed of light, a departure from the Newtonian approach. Notably, this work foreshadowed certain fundamental aspects of his later complete theory of general relativity. Now, I know, is it coming a little bit vague, what I am telling in English? Okay, I will explain you into the next part of the video what it actually means. Now, the most important idea which Einstein perceived is this one. The source of the gravitational potential is not only the mass of concrete bodies, but also the equivalent mass of the energy of the gravitational field itself. Now, what do I mean by that? It means that the Newtonian gravity during that time used gravitational potential as a single scalar field to describe the influence of mass. But general relativity has a more profound view. It explains gravity not as a force but a curvature of space-time, and most importantly, you see, it includes all forms of energy, including the energy of the gravitational field itself. Now, because we are including all forms of energy, and already we know that energy and mass is equated by this equation equals to mc squared, that means any form of energy, not just mass, contribute to the curvature of space-time, and therefore leads to the curvature of space-time and gravity, which is shown in the last right-hand side, I would say, schematic diagram. So what we are approaching, or what Einstein approached in Prague, is that the equivalent mass of the energy of the gravitational field itself is the source of the gravitational potential. Now remember, this is the time when we are talking about the static gravitational field. So what could be the main highlights of this part is that the gravitational potential is represented by a single scalar function, which is, it can be phi or v, whatever. So the focus was basically on gravitation. So out of those 11 papers which I just told, 6 dealt with relativity, and this marked a shift from his career work on special relativity. The equivalence principle, which is articulated clearly, the principle states that the effects of gravity are indistinguishable from those experienced in an accelerating reference frames. And the gravitational redshift and light deflection, the equivalence principle implied two effects, that is gravitational redshift and the deflection of light by gravity. So this was basically, I mean to say, the highlight, the basic highlight of his foundation, which was not yet. So G, if I consider to be that to be a kind of a gravitational potential, not the metric tensor, the field itself can to some extent contribute to its own strength. So if I take this part, I mean to say, if I take the general relativity, it suggests that the gravitational field itself can do to some extent contribute to its own strength. This is because the energy of the gravitational field can act as a source of gravity, although the effect is believed to be very small, negligible. So different sources, all the forms of energy, not just mass, is a basic idea which was important in general relativity. And Newtonian gravity does not fully capture this complexity. So you see the mechanical, thermal, sonic, nuclear, I'm just giving examples, gravitational, electromagnetic, kinetic, chemical, all of this, as you can see, actually contributes in developing general theory of relativity, or specifically I would say all this actually contributes to the curvature of space-time, which is to be considered as gravity later. So can we summarize, looking into this, that general relativity goes beyond the limitations of Newtonian gravity by acknowledging that all forms of energy contribute to the curvature of space-time and hence to the overall phenomena of gravity. Now, this was actually not right. Remember that Einstein still assumed that the gravitational potential was represented by a single scalar function. So the space-dependent speed of light and the theory developed was restricted because it was only considering what is called the static gravitational field. Now, if we consider the first part, that is the static gravitational fields, this theory focused during that time on static gravitational fields. This means it could only describe situation where the distribution of mass and energy was not changing over time, but it changed over time, as we see. Real world scenarios like planets orbiting stars involve dynamics, situations where the gravitational field is not static. So this limited the applicability of the theory. Relying on a single scalar function to represent the gravitational potential was not sufficient, because general relativity, which Einstein would develop later, uses the metric tensor, a more comprehensive mathematical object, to capture the full complexity of space-time curvature caused by mass and energy. Now, this work, which Einstein did during Prague, was actually coming in context with another famous physicist, not so famous, but arguably a very famous physicist. His name was Max Abraham. Now, Einstein's work on gravitation during his Prague tenure was significantly shaped by a scientific dispute with the physicist Max Abraham, who is known for his contribution to electrodynamics and electron theory. Now, Abraham holds the distinction of being the first to publish in January 1912 a comprehensive theory of the gravitational field within the framework of Minkowski's space-time. As you see that Einstein was impressed and then reacted, and he wrote to his friend Michel Bessot that at first for 14 days I too was completely bluffed by the beauty and simplicity of his formulas, Max Abraham's formulas. Now, this is the original paper which is presented by none other than Max Abraham to Tullio Levi Civita, and we know the Levi-Civita connection and into the mathematics, how important it is. And if you go through the internet and find out, there are a lot of research papers, articles, there are opinions. Some say that it was not Max Abraham, it was Einstein. Some say that it was Max Abraham. So we are not going into those type of a controversy, but the most important thing is that in this controversy, which there are a few letters also which Einstein have written to Max Abraham, and so both of them actually develop very important insights on the theory of gravity, and that is most important for us who are looking into science. Now, staying in Prague, Einstein could never forget the beauty, the historical monuments and everything in Prague, where he developed the most important ideas of his life. And in his book, although this is not the original Czech edition, Einstein wrote that I am pleased that this small book would now appear in the native language. And if you read through this, you will see that he tells that I had already conceived in 1908, he must have meant 1907, in the quiet rooms of the University of Vincinia Street. I just show you the photograph where we used to work, I'm to say the Charles University. And I discovered that the principle of equivalence implies the deflection of light rays near the sun by an observable amount. In Prague, I also discovered the shift of spectral lines towards the red. Now, you see, he never forgets to, acknowledge or tell that, yes, it was the tenure of Prague which carried a very important part. So that is why at the beginning of the video, I told that we would be dealing with the three important parts and also looked into the mathematics and concepts of general relativity. He further writes that the decisive idea of the analogy between the mathematical formulation of the theory and the Gaussian theory of surfaces came to me only he returned to Zurich, and he came to know about Riemann, Ricci and Levi-Civita. However, there was a problem with Mileva Maric and Einstein, which created a lot of disconcert, and his former spouse was constantly finding it discontent in Prague, and he was not able to find out the similar kind of a situation because it was unfamiliar with the Czech language. And recognizing this strain, she constantly told Einstein to move away to Zurich, where he would be in a German-speaking community. Zurich, 1911. In the chronicles of academia, Zurich Polytechnic stands as a beacon of enlightenment, its storied halls echoing with the whispers of scholarly pursuit and innovation. Founded amidst the throes of the 19th century, Zurich Polytechnic emerged as a bastion of erudition, its foundation laid upon the noble principles of scientific inquiry and academic excellence. Now, this is the building, and this is called the Federal Institute of Technology, Zurich. And in German, I'm sorry, I really could not pronounce the German word. It is called Eidgenössische Technische Hochschule Zurich. Yes, it is called Eidgenössische Technische Hochschule Zurich. Here are a few highlights. Founded on 7th February by the Swiss Confederation. It was had a mission to educate engineers, and it's still continuing on science, technology and mathematics. It included 22 Nobel laureates, 2 Fields medalists and 3 Pritzker Prize winners, and obviously Einstein was one of them. And it is still considered to be one of the best universities in the world, 20 best universities in the world, and its 16 departments span a variety of disciplines, varied disciplines and different subjects. Now, it was Marcel Grossmann, I would say, a very good friend, philosopher and guide of Albert Einstein. He was appointed as the Dean of Mathematics at the Mathematical Physics University in Zurich. This was, during that time that his initial endeavors immediately was to call, as you can see from Prague, Einstein was called directly to Zurich. And he was basically, he was a friend of Einstein, so he was inquiring if the renowned physicist would entertain the notion of reuniting with the ETH community in Zurich. Now the question was that Einstein already got good offers from Utrecht and Leiden, and he would have been very close with none other than Hendrik Antoon Lorentz, whose Lorentz transformation, Lorentz boost, and everything related to Lorentz mathematics he was using in special theory of relativity, and would include that into his further mathematical formulation. So he would have taken the offer going to Leiden and make a kind of a companionship with Lorentz for his further scientific endeavors. But the question is that he went from Prague to Zurich. Now the question is that, did he went because Mileva Maric was constantly pressing? She was not happy with the Czech community. She was feeling alienated. So shall Einstein's journey to Zurich be deemed to be prudent choice, forsaking the proximity to Lorentz, whose profound influence permeated the very fabric of his works on relativity? Well, this is what we are going to look into the next part of the video. Did Einstein made a right decision to move from Prague to Zurich instead of going to Leiden and working with Hendrik Antoon Lorentz? Well, that is what we are going to the next part of the video. And I'm immensely thankful for watching this video, which I've just started this series of Einstein's General Relativity. If you have liked this video, please click on the subscribe button and click on the bell icon to get all the notification from Physics for Students. This is my email ID and this is my other channel. Please don't forget to subscribe to General Relativity Explained, and you can follow me on my Facebook, LinkedIn, Instagram and Twitter account. That's all for today's video. Thank you very much for watching. Please do let me know in the comment box how did you like about this video. See you very soon with few other videos, and this series on stories of general relativity is still going to continue as we will embark on the next journey from Prague to Zurich. Thank you very much for watching this video.